Hi everyone and welcome to my YouTube channel. So in today's video, we'll be continuing our review for the IMO 2023, which was held in Japan this year. So in the previous video, we discussed the problem 1, and in this video, we'll be discussing problem 2, which is a nice geometry problem. So what are we waiting for? Let's get started. Alright, so the problem statement goes as the following. We're giving a triangle ABC, as you can see, acute triangle, which has the following condition: AB is less than AC, and we've got the circumcircle being omega of ABC. Then we have the midpoint of the arc BC. So we have the midpoint of the arc, but this actually midpoint of the arc is not the small arc, but the bigger arc, the one that contains A. So here, in the following diagram, we have triangle ABC, we have the circumcircle, as you can see, and we have the point S, which is like this one here. This is the midpoint of the arc. Okay. Next, we have we draw simply a height, a perpendicular from A to BC. That's the same as an altitude. That meets BS and omega at D and E. So as you can see here, we have our point D, and here we have our point E. Simply, we have 2 points. One is the intersection of BS and the altitude. The other is just the circumcircle and the altitude. Okay. Next we have a line that's parallel to BC, through D. So from here, this line. So this line simply is parallel to BC, and this line is going to meet line BE at L. So as you can see here, BE, this one here, and this line parallel to BC, they meet at one point, that is point L. Okay, next what do? Next, simply we draw the circumcircle of this triangle, here, D, B, and L. We draw this circumcircle of this triangle, and now we have after we draw this circumcircle, we intersect it with our original circumcircle of our triangle ABC at point P, this point. Next, here is actually the question, what we need to prove. We need to prove that the tangent from P to this circle and line BS and the angle bisector, they all meet at one point. Or in other words, we can just say if we let T be the intersection of the tangent from B and BS, we need to prove that this point T lies on the angle bisector of triangle BAC. All right. Okay, so let's see what we have in our diagram. So first of all, we have triangle ABC. Let's analyze our points one by one, because this is a very important step after we simply draw the diagram. Because by the way, as we always say, drawing a precise diagram is very important when solving IMO questions, because if you don't have a precise diagram, you might have wrong conclusions, you might not be able to see some clear stuff, and when you have a good diagram, you have lots of good things. For example, you can sometimes guess things. For example, you might guess 3 points are collinear. You might guess one angle, for example, we have a perpendicularity maybe. And another good thing, sometimes you might guess a thing and then you can check it on the diagram. So for example, you can check here, or sorry, not in this question maybe, but in general, we can check, for example, if two things, let's say perpendicular. So maybe we guess that these things are perpendicular. We check them. Are they perpendicular? For example, let's assume that we guess that AE and BC here are perpendicular. If our diagram was for sure precise, we're 100% sure, we can simply see from here that yes, indeed they are perpendicular. And clearly it's not a coincidence, because our diagram is precise. So we know that we need to to work on this. We can prove this, right? So always having a good diagram is always a good thing and an essential thing when solving IMO questions or any Math Olympiad geometry question. All right, so don't be lazy. Learn like how to draw a good diagram. Even if you spend some time during the exam, it's worth it. Okay, next, after now like we have a good diagram, of course here like I'm cheating because I'm using like GeoGebra here, but like when you're like doing it on papers, you can like also produce like a precise diagrams, just like as this quality of like this diagram. All right, so now like let's analyze our diagram step by step. First of all, we have a triangle ABC, we have a circumcircle. Okay, everything is good here. Next, we have this point, like the midpoint of the big arc BC. All right, so what is this point exactly? For example, right now we can do some angle chasing because we know what is like this, like what is this angle here, like of this arc. It's like half of B plus C, right? So it's B plus C over 2. What is B plus C over 2? It's just like B plus C over 2 is just like 180 minus A over 2. So it's just 90 minus A over 2. So for example, we can like do some angle chasing here. Like this is, for example, this angle here is 90 minus A over 2, right? Of course, like when I'm speaking about like angles here, I don't mean like when I say angle of an arc, I don't really mean the angle of the arc. I mean the angle that is like the angle opposite to the arc. So for example, when I say like this arc has angle like 90 minus A over 2, this is wrong actually. This like should be 2 times 90 minus A over 2. But like let's agree on this. Like I don't want like usually like you are not interested in the measurement of the angle of the arc. So like let's always like just denote to these as the angle of the arc. All right. So right now we have 90 minus A over 2. Good. Okay, of course like this one like the same thing. But actually we can even like see what is this angle easily. What is this angle like here? Of course it's just like a big angle here, 90 minus A over 2, or like B plus C over 2, minus this angle here, which is C. So it's like B plus C over 2 minus C. So simply it's just B minus C over 2, right? B minus C over 2. So we can write it here as well. B minus C over 2. All right, we know some angles, which is good. Okay, so here actually we have a midpoint of the big arc BC. Like actually the more like the nicer point is the midpoint of the smaller arc. Like I always like to call this point the golden point. So like let's say this point is here. Maybe let's see, should be here. Okay, so like let's call this point S prime. I like to call this point like the golden point because it has lots of nice stuff. For example, first of all, the midpoint of the arc BC, of course, naturally it lies on the circumcircle because it's the midpoint of the arc. Also, it lies on the angle bisector, the internal angle bisector. So in this case, it lies on line AT. So for example, if we extend like here our line, it should be somewhere here. Okay, so let's take it there. Okay, so it lies on the angle bisector. Also, it lies on the perpendicular bisector of BC. Like, of course, because this is equal to this, like an isosceles triangle. So as you can see, like it satisfies lots of nice stuff. Also, like one clear thing actually, because you have a midpoint like above and below, like of the bigger arc and smaller arc, then that just means that this is a diameter, like SS prime. That's why I called it like S prime here. So this is a diameter. For example, like we know that this angle is 90 maybe. Like this is one like a good thing. All right. So as you can see, like putting S prime here might be a good idea, especially that we need to prove that AT lies on the angle bisector, or like is the angle bisector. All right. So for example, now we just need to show that AT and S prime are collinear. Okay, now let's continue our like question. Next, we have an altitude from A. Okay, like standard thing, nothing new. Like that's a good thing. We're familiar with altitudes, no problem. We just intersected with the BS at point D. All right. Also, we intersected with the circumcircle at point E. All right, no problem here. We can like here do some angles, of course, because we know, for example, that we can like know what is the angle of this one. Of course, 90 minus B, and like other angles as well. All right, what next? Next, we take a point like from point D, we draw a parallel to line BC. So let's like put that because we might forget it. The parallel condition here. Okay, so we have a parallel condition. Of course, what does that mean? That simply means that this angle is 90 because the altitude is also perpendicular to this line as well. Okay, what next? Next, like we define point L as the intersection, as we said, of this line and EB. Very good. Now we have our point L. Now, like the complicated stuff begins here. We suddenly draw like a circumcircle of triangle TBL, and now we have like a point, an intersection of two circumcircles, like two circles. Here, like things get a bit like messy because like we don't really know lots of stuff about point P. Although, like it satisfies some like nice stuff. It lies on the circumcircle of triangle ABC, which is good. That like gives us some angles. We can do some angle tracing. Also, it lies on like the circumcircle of angle LDB, which is also good. It like gives us like a kind of some like angle tracing. All right, but still like it's not that like a good point. And like even worse, now we take this like not very good point and we draw a tangent from it to like to this circumcircle, like LBD. So like this tangent here, and now we intersect it with BS at a point T. And of course, as we said, we need to prove that three points are collinear. All right. So far, like we've done some angle chasing. Of course, like one thing we can add here. By the way, like let's make this smaller here. B minus C over 2. For example, because of the parallelity here, we can find this angle. This is also 90 minus A over 2. So we can like put this is 90 minus A over 2. Okay, for example, also we can find this angle. This angle is the same as this angle. What is this angle? It's like EC. What is EC? It's the same as this angle. This angle is just 90 minus C. So we can simply see that here. 90 minus C. And this one as well is just 90 minus C. Okay, like we have lots of angles, which is very good. Of course, like we can know this angle as well. All right. Now what about like points P? Like, okay, now we've analyzed all the points except point P. Like as we said, it's a bit like messy because like suddenly we draw a circumcircle and we have an intersection of two circumcircles. So we need like to know some stuff about it. We can do some angles like here, very good like thing, but still like what exactly like can we do here? All right. So as you can see, like we're kind of stuck here with point P. Like what can we do with it? Because if you cannot deal with like point P, then you cannot deal with point T, like which is like more important point. So here actually comes a very good thing that I told you like before. Having a good diagram, precise diagram, is very helpful. So take a look. I want you just to take a look at this precise diagram and try to tell me like one thing about P. Like try to think yourself, like just take a look at the diagram, at this diagram, and try to guess something special about point P. All right, so take a look. Point S, point P, and point L. Don't they seem really collinear? They sure do, right? And like the diagram clearly speaks about that. And simply like we can check. Like you can take your ruler and check with your diagram by simply checking like this. You will see that of course they are, and then like we can start like doing some angle tracing to prove that. So as I told you, like having good diagram is always like a very powerful weapon because it gives you some like ideas to try to work on when you're stuck like in the question. Okay. So now, as you can see, clearly they are like collinear here. Okay. Oops. All right. So how can you show that they are collinear? Like we have guessed that on the diagram. Now we need to prove it. Okay. So what can we do to prove that this is collinear? Let's see. What can we do, like some angle tracing maybe? For example here, let's think. Okay, so for example, if we like join this, we can find the angles, right? Remember, like we need to use the fact that this point is the intersection of two circles. So we need like to use the two circles, like the angles of two circles. So this is very powerful thing. Like if we like connect the radical axis like P and B, it will be good, because now what is this angle? Like first of all, this angle is what? It's 90 minus A over 2, right? It's the same as this. Okay, very good. So we already know this is 90 minus A over 2. But at the same time, what is this? Like this should be 90 plus A over 2. But how can we prove it? Easy. Is like this arc, a big arc like here. This is already 90 minus A over 2. And this is just A. So 90 A minus A over 2 plus A is just like 90 plus A over 2. So we're done. So indeed, like they are collinear. Okay, this is very good. All right. Okay, so now we know some stuff about point P, as you can see. So we know that S, P, and L are collinear, which is very good. But what next? Like, okay, we know like these 3 points are collinear. What can we do next? Okay, so let's like right now think about how can we prove that the 3 like this point lies on the angle bisector, like point T lies on angle bisector, or we can say that A, T, and S prime are collinear. How exactly can we do that? Like we have this weird like condition of having a tangent to a random circle at a not very good point P. So as you can see, this is a bit like difficult. We don't have lots of information. So what can we have, like some tools or some ideas to help us here? So like when you're stuck like in geometry, like in such like questions, like usually you should have some tools like prepared for like such cases. For example, like you should try to think, can I use like complex coordinates, barycentric coordinates? Like we have lots of tools like of course in geometry. For example, these are some tools. We also have some projective geometry. We have like lots of theorems like that. So one actually very like common let's say trick, or not a trick, like very common and useful trick here we can use is to apply a theorem that's like lets us handle if we have like 3 points, we need to prove they are collinear, and we have like a weird tangent condition. Like maybe this like is suitable to apply like here Pascal's theorem. So what exactly is Pascal's theorem if you're not familiar with? Okay, so let's like discuss it quickly. So let's say like we have a hexagon, A, B, C, D, E, and F. Okay, so the theorem says like this. If you write like A, B, C, D, like D, E, F. Okay, if you take, of course it's cyclic, we are assuming it's cyclic, AB intersection with DE, then BC intersection with, okay, so we always like skip 1 point, so here like we skipped C, like to write this, then like we took BC, so we skip now D, so we have EF, and finally we have now CD, now we skip E, so we get F and A, so FA. Okay, so these 3 points, like the intersection of all of these, like these 3 points are collinear. This is like called Pascal's theorem. It's very powerful because like it's like not only applicable to hexagons but even pentagons. How exactly? Okay, so here like is the nice thing about it. So even if you have a pentagon, you can apply it, but you will tell me how exactly. Like I cannot now put like 6 points because I just have 5. No problem, you can repeat a point twice, and this is like the fun actually. So let's say like you have this case, So you can like repeat a point twice. Like you can, for example, say AA, B, C, D, and E. But what exactly like does AA mean? Like now we want to intersect AA and CD. Well, guess what? What is AA? AA is just the tangent to this circle at like A. Well, like you can think about it logically. Like if you have like a circle and you take 2 points, all right, like this. But what if you take this point closer, like this? Then you take it even closer and closer and closer until like it's the same point. So you will get like a tangent. So this is like the powerful, why like Pascal's theorem is a powerful tool to handle like bad tangents. Like as you can see, we don't really care like what is this tangent. We just like now it's like we consider it as a line. So now like for example, one of the tools that we should think in our question, because we have a tangent and not very cool tangent, we might think about Pascal's theorem. Can we use it or we can't? Okay, like it's a question that like you should ask yourself during like you're solving this question. Okay, so now, for example, here, if I want like to use this fact, I can repeat point PP twice, right? And of course, clearly, I need to use like this circle, like the small circle here. Okay, so clearly, I need to have like PP here. But what else? Like of course, I need to have 6 points, right? Like PP alone is not enough. Okay, like one very very clear thing here. We want to have our point T, right? So we should think about it logically. If we want like to find this point, then we should include PP twice. Then we should skip a point. Then we should put BD, right? We should have like BD because now if you have like BD, then like the intersection gives you point T. Of course, then we need to think about like point A and S prime as well. But right now this is like enough. Like we have already guessed 4 points. So like let's put our guessing here. So we have P, we skip a point. Then what do we put? Yes, okay. Next we put like what did we say? Yes, DB. Okay, and then we skip also a point. Like we don't know what are these points yet. But okay, now like we have at least PP and BD or DB, like they give us 1 point T, which is very good. Now like we need to have established point A and point S prime as well. Okay, how exactly can we do that? Let's think about like point A. What exactly can we do to establish our point A? Well, let's see this point A, where does it lie? Like we don't have really like nice lines here because for example here we had already like 2 points here for T and a tangent for P, but this is not very good here for A. However, if you think about it, we have this good line like AD. This is the altitude, right? So if we put D here, like if we use basically this, which is like this and P, maybe this will give us like something about point A. However, like this point is not defined yet, so we need to define it for sure. So we need to define this point here. Okay, what should we call this point? Well, take a look. Here we have this is 90 degrees, right? So that just means that this is a diameter, like L, and this point is a diameter. So it makes sense like to call it L prime, right? L prime. All right, so now this is very good. So now we should probably put here L prime D. Okay, now we have like L prime D and P something. So that also gives us another guess for PA, right? Like we should have like AP and something. So unfortunately, we need also to define like another point. We don't have it in our diagram. So let's like do this. We need to join AP and intersect it with the circumcircle. Oops. Okay, let's accept that right now. All right. So now we have AP and this point. Okay, now we don't know like anything about this point. Let's call it X for now because we don't know anything about it, right? So now we have x. So guess what? Now we're done with our hexagon. We know what like are the 6 points for Pascal, and now we need to hope that the third like points will be S prime. Like else maybe like our whole like work is like trash. So let's hope that now if we like apply Pascal here, we'll get S prime. Of course we can check that with our diagram. We don't need right now to prove it. So okay, now like we've handled A, T, now we need to check S prime. Okay, so what did we miss? We put like PP, we took L prime D, so we missed like this one, PL prime and PX. So let's hope that indeed S prime lies on these. First let's check PL prime, like here, P and L prime. Here. Well, that's good news. They seem to be like collinear, right? So probably like we should be done now. Like now we have all the ideas. Now like our question should be just a matter of angle chasing, right? For like all of these, we just need to like show they are collinear. Okay, so P, L prime, S prime are collinear. Well, we need to prove that, of course. So let's try to do some angle chasing. How can you show that P, L prime and S prime are collinear? Okay, let's think. Okay, so one idea is the following. Like, remember, we have S and we have S prime. They are a diameter, right? Like this all is a diameter. So one idea like is to use this. We already showed that these are collinear, so we can use them. So this is 90 degrees, right? This angle is 90 degrees. SP, S prime is 90 degrees. So if we can show that SP, L prime is 90 degrees, then you are done. If we can show like SP, L prime is 90 degrees, then we have showed that they are collinear. Well, is it? Clearly, yes. We can use the fact that these three are collinear. So we can simply say that this is 90 degrees. Clearly, this is correct because we already defined L prime to be the point such that L prime are collinear. So yes, it is like this is 90 degrees. So yes, we're done. So we showed that now P, L prime and S prime are collinear. Very good, but we're not done yet. We have our last 3 collinear points, which are the following. Like from here, BX, right? BX. So should have something like this. BX and S prime. All right. Come on. All right. How can we now show that these points are collinear? Of course, we need to do some angle chasing, but we have a problem here because we don't know anything about point X. We defined it like to be intersection of the circle and the line AP, which is not a very good thing. So let's anyway think about it. Like if we have S prime and B and X are collinear, then what do we have exactly? Well, take a look. One thing like we can notice here. Okay, let me use now red. We already have lots of blue. So S prime and point P and S, this is 90, right? This is 90. Because as we said, like this is the diameter. All right. So what does that mean? Simply that means we should have XBS 90 degrees. We should have this is 90 degrees. What does that mean? Like if XBD is 90 degrees, that means like my dear friends that point X is nothing but like the point that makes XD a diameter. Like this should be a diameter. So guess what? You guessed it. Like it should be D prime. We should call it D prime. So now like let's define this point as D prime such that like D prime D is 90 degrees. And now we know already that these 3 points are collinear, like D prime, B and S prime are collinear. However, now we need to prove that D prime, P and A are collinear. Now like we need to prove these are collinear. Alright, no problem. Like let's try to do some angle chasing. Let's hope like it's easy. So we have D prime, P and A. How can we show they are like collinear? Let's see. All right, so like here we have like one idea that like we can just show that these two angles are equal. Usually, like when you have two lines like this is a good idea, like to prove that these are equal. This will be enough to show that they are like collinear. So anyway, like this is already known. We already agreed that this is b minus c over 2. B minus c over 2. So we just need to show that this is b minus c over 2. So how can we find like this here? So we basically need to find this. Let's think about it. Okay, we already like have here a diameter like 90 degrees. So okay, we simply just need to find this, right? If we can just find like this here, then we'll just have 90 minus this. And guess what? We already like can find this from here in this triangle. What is this angle? It's just like 90 minus c. It's actually just c plus a over 2. C plus a over 2. So this angle is just c plus a over 2, which means that this is just 90 minus c minus a over 2. Okay, what does that mean? Like let's substitute a as 180 minus b minus c. So we'll have, yeah, simply we just have b minus c over 2 actually. And guess what? That means they are collinear. So now we've shown that S, P, and L are collinear. So guess what? Of course, like right now we should delete x and put d prime. And now, my dear friends, we're done. Because if we now apply Pascal theorem on like this 6 points, then we have PP and DB, they give us point T. PL prime and BD prime, they give us point A. And L prime D and D prime P simply give us our point S prime. And that means that we have 3 points. Our 3 points are collinear, which means that T indeed lies on the angle bisector. And hence we're done. IMO 2023, problem 2 is finally done. Alright, so as you can see, like this question was really nice geometry problem. Like we simply like confirmed lots of things here. First of all, like a good diagram, a precise diagram is very important. As you can see, when we draw a good diagram, we immediately guess that the 3 points were collinear. Like our 3 points were collinear, which like P and, if you remember, A, and the other point was, I think, L. Like they were collinear, which gave us, which helped us a lot actually in like proceeding with the question. Another thing that's good, always like you should analyze your points, put some angles. Also, that helped us like when we wanted to do the angle chasing. That helped us a lot. And finally, like we should know that Pascal's theorem is a very powerful tool. Like if you can turn your question into a collinearity question, like you need to prove 3 points are collinear, and you have a circle. Like of course you need to have a circle, like a cyclic, at least cyclic quadrilateral, like to have like some points on the circle. Then like you might just be able to apply Pascal's theorem. Of course, sometimes you need to define points, especially like when you have like a good think like here, for example, we wanted to escape our ugly tangent, like P, the tangent from P to this random circle. So we just applied Pascal and we put PP. So it's a kind like of an escape, like we escaped like these things by simply like putting PP, and we were done, right? We just like needed to define some points, and we like did some angle chasing, and then we simply like done. So the key point here was to know how to apply like Pascal's theorem in a good way. All right, my dear friends. So I want you like to tell me in the comments what like you think about this question. Was it hard for you, or like maybe you guessed like Pascal's, or maybe you like, of course there are other solutions as well, like not involving Pascal, but we just presented like one solution that's like I think is logical and a good thing like to learn, because Pascal's theorem is a very powerful tool you should like master how to use. Of course, like we'll be continuing our review, so please like, share, and subscribe to my channel, and see you guys in the next video.